Hello, this is part one of the structural geology lecture. This is going to be a lecture that helps you understand that sort of phenomenon of understanding objects like this block. So you've probably driven around and seen, especially in road cuts, areas that look a bit like this block, in that you'll see lots of sedimentary layers that appear to be tilted. Or perhaps you've been flying over some vast desert landscape and seen something from the air that looks a little like. So, we're going to equip you with the power to communicate to other people what is happening on 3 dimensions based on information you've extracted from the surface. What you see in this diagram is an example of what you have here. It's part of what and then wherever two planes intersect, this line mark of intersection is the line of strike. And this line of strike is always horizontal. And the strike direction is simply the compass bearing of that line. Now, it would also be useful to know how steeply tilted and which direction this plane is tilted. Because, for example, in the example of this block model we have here, let's see if we can find it, yep. I can hold this if, for example, if I have this block like this, you have our strike. But for any given line of strike, you can have this block be tilted a wide variety of ways. You can even have it go upside down. Understanding what things are upside down, for reasons I'll explain in a few minutes after I get you started on the whole strike and dip little bit here. And so to describe this direction of tilt, we use a second term. That term is called, so dip is the direction and magnitude of the tilt / inclination of that surface with respect to the horizontal. We break the dip into 2 different components. The first component of the dip is the dip direction. This is simply the direction that is down. So you may notice I've added a little compass on here. And so unless it's a little elongated, it's on the horizontal surface. And so in this case, your green layer here is dipping to the east. That direction. The other component of the dip is the dip angle. So in this case, looking at this, just sort of trying to eyeball the center angle intersection, you can see that the dip angle here is probably, this looks like, what do we call it, 30 degrees? We're going to call it 30 degrees. So in this case, your dip angle is about 30 degrees. So now you need a nice, compact, user-friendly, efficient symbol to communicate the direction of strike, the direction of dip, and the dip angle. This is what we call a strike and dip symbol. We're going to draw one right about now. So if you draw a strike and dip symbol on this chart, here's what it will look like. Follow very closely. So I'm probably drawing it right here. It would look like a sort of a flat, very squat T. Let's break this strike and dip symbol. And what we'll do now, we'll switch to map view, and I'll break down the component of the symbol and all its sort of various pieces. So now I've drawn a map of our outcrop. So you can see this area that's where the green layers intersect the plane of horizontals, just a little green stripe on here, kind of like a little bit like, let's see if we can get this to, a little like this green stripe here. This now we're just taking this around more and let it side like this. Now we want to go to this map view and communicate the fact that what's actually happening is this green layer is tilted towards the east at about 30 degrees. This is where our friend, the strike symbol, pops up. We're just going to draw one in real time on this map. So again, it's going to look like this sort of very squat T symbol, like that. And then we're going to put a little label on it, 30 degrees, to indicate the dip angle. And now we have all the components of the strike and dip symbol. We have the strike marking this very flat top part of the T. We have your dip direction, which is the direction that this inclined surface is going downward. Another way to think about it is if you can, the dip angle is the direction that, if you were to take a marble or a drop of water, which direction would be the direction of steepest descent. So now we're going to show you a couple different situations and different strike and dip symbols that'll explain different types of rock layers, how different rock layers in different situations. We're going to be looking at these models from two perspectives. Perspective of the oblique view. So if you have this, this sort of imagine this is the surface of the Earth, and you take a little wedge out of it, slice it up like a little slice of cake or something like that. Tasty. Then you're kind of looking at it on an angle, so you can kind of see several different faces of this cake. And of course, the more traditional map view. What would this sort of outcropping? You put the piece of cake back in the cake and you took away all the cuts. How would you map that rock ledge? Well, your bird's eye view, if you want to make it more. So, for example, we have a bunch of layers that the first one, this is going to look a heck of a lot like the first diagram we did, but I want to give you a little practice labeling these things. So what you're going to want to do here is first draw a couple strike and dip symbols. In this case, the dip of all of these layers is set to the same direction and of the same magnitude. I'm going to guess that looks a little like, let's put it about 50 degrees. So I can now say that it is striking north-south. And you can put one here or the other. It doesn't matter. This is the strike direction. It's reversible. It doesn't care whether you're going this way or that way, as long as it lines up and is parallel. And your dip is going to be 50 degrees to the east. That's how you might write it in your field notebook. Now let's try another example. And if you just look at the space of the rock, you think, oh, this is just a horizontal layer. In fact, there's a couple places in the greater San Diego region where this is exactly the case. You see what looks like perfectly horizontal layers, but that's because they are either dipping at you or dipping away from you. So in this case, we draw our strike and dip symbol. Or just fill that in to make the color. We draw it like so. We're going to put 45. By the way, just for the reference, beds can dip at just about any angle you want. They can even be upside down. We're just using angles between about 30 and 60 because they're a little bit easier to draw on the board. All right, so in this case, you'd have a striking east-west and 45 degrees to the south. Messier. Fit perfect east-west here. See if we can make it make sense. This will be a challenge for me, by the way. So now we've upped the ante a little bit. One, I've given you a shallower dip angle. Two, I've made the angle of strike not north-south nor east-west. I think you're ready for this. Let's give it a little shot here, see what we can sort of calculate out. So one thing is, because you're looking at this at a little bit of an angle, dip angle is going to be even shallower in this direction. Still see a little bit of it. Also notice how the exposure of the outcrop at the surface is a lot wider than the actual thickness of the bed. This is a nice little illusion. So it's not exactly the optical illusion, but it's one of those ways that if you're not careful and don't pay attention to the depth angle when you're looking at a map view, you might misinterpret it for being thicker than it actually is. There we go. So now we have a, let's say it looks like it's striking northeast, southwest, and dipping about 20 degrees to the southeast. Whoops. Example of why you should always write stuff down before you see it. This is actually striking north 45 east, or some people use the convention striking at 45 degrees. They use the 360-degree compass. It's either way is fine. A geologist will know what you're talking about. And it's dipping 20 degrees to the southeast. All right, got two more, then we'll set your... So now we have a situation where things have been really turned to the side. Literally. We have a symbol for beds that are dipping perfectly vertical. That symbol is this one. Of course, it looks a hell of a lot like the compass rose I did. I'm sorry. This just means strikes north south. All right. Final thing we're going to show you is what to do when you know for a fact you're looking at something upside down. And the reason you want to know if your layers are upside down is that there was a drill core done in Antarctica back in the late 90s where they found evidence in the sedimentary record for a major shift in climate that where things got abruptly colder over a short interval of time. They called it Event 1. And they're trying to figure out how this happened and what would cause this rapid onset of glaciation. It turned out this event never happened. What happened instead was that they had drilled into ice that had been overturned by all the shearing at the base. So a good example of this would be if you found like a layer of shale or siltstone that had mud cracks on the bottom. Another obvious indicator that it was clearly upside down. In this case, the symbol used to denote a layer that's been overturned would be the following. Starts out like your regular strike and diff symbol, but now what you got is you do this little loop-de-loop, and there you go. And that's how you denote an overturned layer. Now we're going to look at a couple structures. Now we're going to, next part, we're going to look at some common structures and the strikes and dip symbols associated with them and what they look like in map view.